Hello everyone, welcome to my YouTube channel. My name is Ruel Kosaev. Today we're going to do a second video about Ardamax Keylogger. So let's get going with this. So as a reminder, we have a keylogger basically which tries to keylog or log our keystrokes and basically to steal sensitive information, any possible thing from our computer. As we've seen in the first stage, or from the detections or the signature names of each one of the antivirus or EDR software vendor, we don't have something that indicates that is Ardamax. It's most of them are generic, riskware, adware. I don't know really why they call it adware, but whatever. Trojan. So basically we saw some relations to other files, saw some basic details, and we started by seeing the sandbox report of website called Triage. Great website, doing malware analysis and stuff like this. Of course, they're not sponsoring me or something like this, but it's a great tool. And as a typical communication or exfiltration mechanism that Ardamax uses is by using an email or an SMTP server like Gmail or whatever. As we already saw in the previous video, I showed you the blog that I wrote like 1.5 or 2 years ago, and we saw basically the same type of communication. They use some type of signatures here, as Triage can detect. Uses VBS compiler and other interesting stuff, but again, we want to actually validate those by using some reverse engineering techniques. So let's get to the virtual machine that we use. I'm using a pretty, old school Windows 7 machine. It doesn't have any antivirus or something that will interfere with our analysis. So basically, as a reminder, we have here the Ardamax X. Wrote it X and not EXE, so it will not be executed accidentally. And basically, we saw that in the resource section itself, if we use resource hacker, we put the program inside. We have some stuff in the resource section that more for the GUI and other stuff like this. It's a pattern that sometimes malware authors take a legitimate program or take other malware and tries to implement illegitimate stuff inside something that looks legitimate. So if you gonna say like, we have a GUI, we have an icon, you can maybe accidentally think that it's fine, it's everything okay. But if you go deep further, I don't really remember where it were, but in one of those sections, you have a section called cabinet. And we saw strings like 1exe, install exe, and other interesting stuff. We took the magic value of the cabinet file. We validated this cabinet file. Basically, a cab or cabinet file is like raw or zip or whatever, Microsoft format. And basically, we extracted by using a right-click, save bin resource. And from the cabinet file, we extracted 2 of those legitimate, quote-unquote, programs. So basically, now we want to pretty understand the first stage in its inner code. We'll try to do it in the shortest way, of course. We'll try to minimize the time in analyzing this malware, but because of course you cannot analyze each piece of code in there because you have a lot of code, especially assembly. So let's get started. First of all, I want to again do a quick overview. We have a portable executable, 64-bit. It's compiled in Visual C++. It's very important to understand which kind of compiler is used. So maybe it's compiled in Golang or in VB, or maybe it's a VBS script, or it's another type of C++ language like Borland or Borland Delphi maybe. So I have many flavors of code that you can write and actually compile it to a portable executable. So the fact that you're using a portable executable, it doesn't say that it's actually C or C++. It can be even a Python code which is compiled with PyInstaller. It's a program that takes a Python code and compiles it into a portable executable. and you can take Golang and compile it to a portable executable and other codes. Of course, you can use also .NET, C#, for example, also to compile a portable executable. But if you compile a .NET executable and you want to analyze it, you need to use a different tool like dnSpy. So in other malware like Agent Tesla and stuff like this that we'll research and analyze in our next videos, I still didn't decide actually which type of malware or which malware variant or whatever I will research. But if we will research a .NET based malware, it will be used by a software like dnSpy. But because in this case it's actually compiled with C++, so we'll use IDA Pro. A great disassembler takes the machine code instruction or file and disassembles it into assembly. So because it's 64-bit executable, we'll use IDA 64 and open it up there. So let me just real quick throw it there, and we'll also take the load resources to for IDA to parse the resource section itself. And basically we have here the starting program. As my previous recommendation, the previous video, always when you start with IDA, you can use the Control E to see which entry points you have. Sometimes you have more than one. In this case, you have only the start entry point, or you can call it the main program. Whenever you write a program, like in C++, you will have a main function, which the program will start from there. And then from the main function, it will call other relevant function, depends on your code. So in this case, we don't have some TLS callback, which are functions that are executed before the start of the main function, which is a very interesting functionality that some of malware use. In this case, we have basic start. So let's try to understand basically what we have here. So we have the first function, which does some, without going deeply into the assembly code, just viewing the function. So it gets the system time and the current process ID, thread ID. It tries to kind of understand in which state it is. It calculates some, it executes the getTCount function, which you can read in Microsoft official documentation, query performance counter. In the previous video, we didn't see that it actually used for anti-debugging, but we can still see it. Maybe it's used in the code. And then after it's executed, we have here the cleanup of the function. So whatever a function is called, basically it, like we see here the sub RSP28 hex. We can of course also see it in decimal value, so it's basically 14 decimal. And basically what it tells is, okay, take the memory in the stack and subsequent it. And when you subsequent memory in the stack, you basically give more space for the function to take more arguments or more parameters for the execution of the function. But whenever the function is executed, like it's executed all of this code and eventually got here to the pop, basically pops the values from the stack, like I explained in the previous video. Stack works in the way of LIFO, last in, first out. The last value that goes into the stack is the first to go out. Again, if you want to understand more of this, you can either register for my course. I released 3 courses basically. The CMAP, Certified Malware Analyst Professional. You have the CMRE, which is more advanced course, more advanced in the way of that we take malware and actually reverse engineer it from scratch, from zero to hero. And basically I have the CACD course, which will coming soon, which is more about red teaming and how I write tools and how I customize tools and malware for my white hat research and attacks that I conduct on clients or whatever. Of course, everything illegally, like needed. So after the function is returned, the stack need to be cleaned. Okay, so in this case, the stack is cleaned by add RSP28. So RSP is also called the stack pointer, we'll see conventions like SP, which is 16 bits, which is old. You will not see a lot of those, but again, it very depends on the program. You'll see ESP, for example. E is for extended stack pointer. E stands for 32 bits program, and RSP is used for 64-bit programs. This is like basic. So again, you can either register for my course, so you can learn. You have a lot of free content out there. You can, learn. And again, I myself learned most of my knowledge is by myself. Thanks, of course, thank my God and mother, my mother, which gave me a lot of power to do it. And of course, if you want something more methodological and like in a course format, you can always talk to me, send me a message, and I will guide you up. So after the function is executed, the stack is clean. Now we have the call for another function. So we have some functions used here, like startup and sleep and other interesting stuff. We can try to kind of overview. We can use the space button to like change the view of the code and like go in overview what we have here. So we have a lot of functions and Windows API functions that used, and we have exits here, and other interesting stuff. So we can, in order to understand if we have an anti-debugging mechanism or whatever, we can use a breakpoint on those exits, or even before the parameters that which are passed. But in this case, we don't have any something special, so we'll put a breakpoint on the exits. We have another exit here, and let's see if we have something interesting regarding anti-debugging. So let's see if we have more exits. We can change the view again, do some zoom out, zoom in. So we have a lot of conditions here, a lot of checks. One of the things that I like is doing F5 to decompile the code into C code. And then there is a trick, actually. You can take this window and like put it right here. Let's just get it like this. And then you have a nice and cool view, like in Ghidra or other program disassemblers. And you can do like right click, synchronize with IDA view. And then in any code that you're actually clicking on, it will highlight the code and synchronize between the pseudo C decompiled code and the disassembly view of things. So this is one of the ways that I like to work. And I always like to go to the end of the subroutine, see whether something is called, whether a loop which goes and checks, compares some value, compares another value, and takes some data. If we try to go to this function, we'll see, for example, if we go to this subroutine, we can see with the X button how many times it's called. So we can see it's called one time, so maybe it's something specific for the program. So we can go here, it gets the version, gets the module of kernel 32 DLL, which is a DLL that holds functionalities like create process and other stuff. And we have other functions which are called. Okay, so let's see here if we're up. So we have the word title here. So more stuff goes here. Ver check, version, stuff like this. Maybe it's related to the GUI that we saw in the resource section. Okay, so basically we have here create mutex. Maybe it will check whether we have basically so we have here this string instant check. So if this instant does not exist, it will take this function first of all. So if it's not exist, it will go and extract something from the resource. Okay, so we have here 4 Windows API functions. We have the find resource, size of resource, load resource, and lock resource. And we have the fifth also, which is called free resource. All of those 5 functions, and most of the time the 4 first functions, are used for resource section extraction. So let's try to kind of explain and getting into the context. I know that sometimes it's very hard to like understand and go with the flow of the code. It's something that you need experience in. So basically we have the extraction, maybe we need to validate it, of those files. So maybe it's somehow related. Okay, so it's actually an interesting function. We can put a breakpoint here and analyze it dynamically. So it will find a resource with a specific name. The name in this case is populated dynamically. The meaning of populated dynamically is basically we don't have a hard-coded value here, but while we will run this program, we'll debug it, we'll see the actual value. Okay, so if we try to go to this value, so basically it will take the resources, and after the subroutine is ended, and go back and see what's happened. So then we have this test and jump not zero, which is basically in C it's an if. So the if is translated to test or compare with jump zero, jump not zero, whatever, and vice versa. So it will take the resources and create and basically see whether this basically if this instant check value exists. So if it exists, it will go into this red. Okay, so it will go to this routine. If not, it will go and create this mutual exclusion or mutex value. So if the malware will try to run again, it will say, okay, this malware already is running in the system. You don't need to do the same operation again. So it's just a self-check for the malware itself. Okay. So basically, if it has this value, it will go here, do some source. It will zeroize the values of R9 and R8, jump. Then we call this function. Okay, we'll load some string, do some stuff. Just overview of the code. Okay, so it's something, and then if I go back, if the mutex does not exist, it will go and create the mutex. Okay, so this is the basic functionality. And basically, if I go here, try to see, then it extracts the same with vert check. So basically, I can do some trick. I don't need to really debug it for now, I think. But again, the point of the malware for fun playlist, for you to know, it's not like I'm already researched this specific variant and then I'm showing you stuff. I'm going from zero. Like, I don't really touch this variant, this specific variant. And I'm doing this while in the video itself, so you'll see how I approach stuff that I didn't specifically research or analyze. Okay, this is the concept. So let's try to open it again in Resource Hacker. And if I'll put Ardamax EX and go to, if I remember, it was RC data. Yeah. So basically, I see here, let's see if we have the title. We have the title here. Okay. So we'll see if we have. So this is the cabinet file itself. Maybe we have the versions here. Version info. Okay, we have the manifest. So let's see here. So again, let's go back to the code. So we have the instant check and vert check. So let's take this. go to resource hacker. Maybe we have it here somewhere. Regarding the, okay, so command line options. Okay. Why the hell it will have strings like this? Interesting. Okay. Anti-shadow open pros token error. Okay. So pretty interesting. It saves the strings inside the resource section. You can learn more about this malware. Don't cancel memory. Okay, some looks like standard messages, like compiler messages or whatever. For me, maybe I'm wrong. Please select a folder to store the extracted files. Okay, interesting. So okay, so maybe the resource hacker doesn't have all of the resources presented here. So we have the title. Maybe saw it here. We have the ver check. We have the title here. We have the extract opt. So it goes to the extract opt. It like checks the title. Goes to extract option. Maybe it's for the cabinet file. Okay, then instance check, wherever it is here. Okay, so we can go and see where is this cabinet resource name. So let's try to rename, like take this name and search it inside the code. So let's go back to the start of the function, do Alt-T for search, and let's try to find this. Let's do find all occurrences. If you wanted to search from the code that we were before, go to this public start, you can do search up, so it also searches up. So let's do search and see if it can find it. So we have here some strings of this cabinet. So let's try to go to this call. We see here LEA, or load effective address, which basically loads or assigns a string or whatever value, decimal or whatever, to register. And basically a call means that a function is actually called. So basically, if we go to this function, see it uses some function which is called FDI. So okay, interesting function. Let's search it on Google. FDMSDN. So interesting. FDII maybe. FDI copy, for example. Okay, so it's part of the fdi.h header file for C. Files from cabinets. So basically it extracts files from cabinets. So the FDI copy function takes a value, some parameters, the path, some flags, maybe the user, FDI. So for each parameter we have an explanation here. So a valid FDI context handle returned by the FDI create function. So the FDI create function is used and then basically return to this parameter, and it's used by the FDI copy, and the return value of FDI copy, the return value is basically the value which returned in the EAX or RX register, and it indicates whether the function were successful or not. So in this case, if the function succeeds, it returns true, maybe the value of 1, otherwise false, 0 maybe. So we can see it in assembly. So if we go back, we actually see, yeah, it uses the FDI create then takes some memcab value, maybe it has something here into resource. No, I don't see it. Then the FDI cabinet is used, and somewhere here maybe the FDI copy used to extract the content itself. So let's rename it with the N, call it FDI FDI cabinet, and I like to add a suffix to the end of the name, and I'll call it here, whatever. And the here will indicate for me that is a function that I've renamed. So let's do OK, and as I see, it's renamed. If I do X, I see basically it executes only once in the program. So you can see here a lot of functions. If I go and do Control F and search for here, I'll see all of the renamed functions. Okay, so basically I'll do X, cross-reference, and then go back. So it basically goes, oh, here we go. We have the cabinet resource. So it's actually, by using those functions, it goes into the cabinet resource name. Okay, and basically go into extracting it. Okay, so we have here again FDI create, FDI copy, and in the end, the FDI destroy will be used in order to remove the context of the FDI create, which is used also by FDI copy, and eventually this context is destroyed. Okay, so pretty much interesting. We can put a breakpoint in this subroutine. Okay, we can put a breakpoint here and start analyzing it. So basically we use the breadcrumbs from the strings and from the resource hacker, basically, and probably we got to the right function where it actually extracts the content of the next stage. Okay, so let's try to understand before we execute it. So a function that it's calling after the free resource, I think we have here this call. Let's see. Okay, this function executes a lot of times, number of times. Okay, so load string, load local, whatever, goes into some stuff. Try to load some strings or whatever. So it's actually, it may be used to load specific strings from the program and then do something with it afterwards. So I don't really go into the code trying to understand everything because it can take a while. Gets the version or whatever. Okay, so it's go and opening a registry value. So whenever we see registry, Windows API functions used, it's an indication of something is happening in the system. Okay, so this specifically is not something. So it checks the locale, the the language or the keyboard and stuff like this. So I can call it locale lang here, whatever. Okay. Let's go to this function. Goes again into some language stuff. So we can call it also something like this. And again, I don't really go deep into each one of those functions because it can take time. Do one here with this. This is the way that I like to work. Maybe you have better. Some of researchers may prefer to go and execute the malware inside a sandbox or inside a virtual machine and use the programs like Wireshark and Procmon, Process Explorer, API Monitor to monitor the execution and stuff, which is great. But I don't think it's really interesting to go and jump into those programs right away. I think it's better to kind of get the glimpse or the uh, or the feeling of the code, and then maybe, of course, uh, it's not that I'm not using these programs, I'm using them on a daily basis, but again, you can find your own techniques and you can find your own way of working. This is why I like it. Okay, so also go for some locale stuff, solve the copy, they destroy. So let's validate that it's actually the extraction or the drop of the next stage is happening here. So let's call this start address. Okay, this function calls it. Check something. Okay, so with the calling function, the directory. Okay, let's not get too has some use of file decryption. So get the get proc address is basically a function which takes a specific function from a DLL file. In this case, I think it's from advapi32 DLL. So it loads the library, then takes this decrypt file specific function from the advapi DLL. We can validate if it's whether it's from advapi by taking the function here, do msdn. Let's do it in a different window. And let's see whether it's part of the advapi, if we understand it right. And sometimes they write here from which, no, it's .NET, so file decrypt file. Let's use decrypt file msdn maybe. Yeah, here we go. Because of the V, it's kind of confused. So decrypt encrypted file or directory. Okay, interesting. Takes the file name. Okay. And it's part of the advapi DLL, which is a dynamic link library, or part of the advapi32 lib, which is a static library. Okay, most of the case it will be based on DLL. Okay, so interesting stuff. So the decrypt, I want to understand if the decrypt is before or after the function. So let's do escape. I'll call it interesting. Called interesting. Here. Okay. If we want to be synchronized, we can do again F5, and here we go with synchronize it. So basically I want to understand whether the decryption is before the extraction or after. So let's do it like this. So it's like of the decryption. Okay. Gets the disk, gets the volume, sets the current directory. Maybe it uses the current directory in order to do its bidding, whether the dropping or whatever. So file system stuff here. How many times? Okay. So set current directory. So it says the current, it's like decrypting maybe, then sets the current directory, extracts the file. Okay. And again, loads some resource here, whatever. Afterwards goes into this function, UDF file, whatever. Let's see if we have this UDF file. UDF. There is no search or something like that. We'll go with fine. So we have this EU PDF, whatever, find. So yeah, I think Resource Tracker doesn't gives us everything. UP, no, yeah. So basically it takes another resource, loads it, and do whatever it is, and it does an interesting stuff, which is called an indirect call. Okay, so a direct call is basically like calling a function like this, call find resource. It's a direct call. Okay, it's the function is part of the code, and call RBP is like calling something indirectly, because the RBP, for example, the RBP register, which is the base pointer of the stack. If we have the stack pointer, which is the top pointer, we have the RBP, which is the base pointer of the stack. It's like a stack, cubic, or whatever. So whenever I'm calling a register, so it calls something or some value or address, which is initialized in this register in this case. So sometimes we can see it in unpacking or deobfuscation code and decryption and stuff like this. So we can maybe also put a breakpoint here and see whether it tries to do something interesting in this case. So put breakpoint here. I like to call it re-enumeration or reverse engineering enumeration or code enumeration. Basically enumerate the code, kind of trying to get the sense of it, try to put breakpoints on places that I think crucial for the understanding of this malware or whatever, and then I execute it. Okay. Let's see here what we have here. So let's do like this. Let's go to our breakpoint window. So let's go open subview, go into the breakpoint window. Yeah, something I forgot where it is. So disassembly, no. We have here. Okay, here we go. Open breakpoint window, thank you. So we have here those subroutines that we put. Those are the exits, I think. So can go here, the exit one. So I want to see whether it tries to exit the program for anti-debugging purposes. And yeah, so basically, let's go with it. I like to put a breakpoint in the start of the program, like I'll put it here, and try to go with the flow. So selecting the local Windows debugger and do start. So with the help of God, let's get into business. Close those windows. So let's try to go F8 here. See, it goes here. So this exit is not relevant, I think. Maybe it has no, it's not relevant. So I can remove the breakpoint by pressing again F2. Takes the GS30. Okay, which basically it's not the okay. So there are times that you can have the FS30 or GS60 for PEB, the process environment block, which is basically a data structure in Windows which holds the information about process. So if you open Process Explorer and see all of this process and their name and the path and their permissions and whether they being debugged or not, all of this information is part of the PEB, okay, process environment block, which basically sometimes malware like to use it in order to do stuff like dynamic API resolve or some mumbo jumbo stuff, let's call it. Okay, so let's go further with the code, see if it tries to exit or whatever. So it goes looping here around. So I don't want to go with this loop. So what I will do is basically I'll go out from this loop. So basically I see that the loop ends here. Okay, whatever it takes here. So what I can do is basically I have two options. I can put a breakpoint, then press F9 to like execute the debugger till this point, or just in IDA Pro basically I can do F4. Okay, so now F4 basically did the same thing as putting a breakpoint and executing till this point, and all of this without putting or removing breakpoint. So now I'm in the jump 0, so let's do F8 and continue. So did some initializations or whatever. So I don't really see it tries to exit or something. Just want to validate this before we go further. So again, goes into a loop. And again, okay, so now that we are here, so the end of the loop can be either, so it goes here and again goes here. So the end of the loop can basically, again, you can use the space button to see it in this view or like this, which is for me sometimes easier. So I'll basically do an F4 here and hope that it will not exit. Okay, so fine, didn't exit or something like this, so we can see now and continue. Calling the function takes from the data section something that's called start, load something with title, okay, whatever, and then basically it goes to the, okay, so it's now like doing all of this mumbo jumbo stuff with the resource, gets the title. We can just go through it, freeze the resource. Okay, so now that it took the title itself, as we can see here, it goes into the extraction options, as we can see here. Extract options, which is basically this value, whatever. Takes this value and again find resource. So basically we can call this routine resource or RSRC extraction here. So this function is used in order to extract resources, and yeah, so whatever, it takes a parameter, the name of the resource, and basically do its stuff. So we can do, I don't want to actually go again and again with this code, so I'll remove the breakpoint and go here, debugger, and basically run until return, or control F7. Okay, and basically I'm done with this function. And it is returned. Now it's go into instant check for mutex purposes, or in order to check basically whether the malware is executed or not. And we can see it takes a turn and basically it doesn't do something interesting here. So it goes here and we'll call this function. Let's go into the function before we execute. Try to understand what this function is. So yeah, man, some pretty code here. We can use it as a template for the desktop or for Twitter or something. I will not go into all this code, of course. Okay, so do not worry. I want to kind of get and understand, like, tries to compare some string like rex server, register server, whatever, for whatever reason. Okay. And I'm suspecting it will try to drop something into the temp folder. So let's see if we have some function into temp, because I saw this is .tmp extension. So let's try and go to view, open subview, imports, see if we have something with temp. Yeah, so we have something with get temp path. We can do cross-reference here, and we have a number of functions like this, so we can put, so all of them are part, so we have two subroutines which hold those functions. So let's put a breakpoint here, and so let's try to understand kind of what's okay. So let's call it for now temp stuff here, and we have another code or subroutine which the get temp path is used, which is here. So again, something to get drive paths. So try to get the drive, disk free space, and whatever it will eventually drop the next stage. So let's do a rename here to temp stuff 2 or 1, because I'm starting with 0, and do here. So yeah, great. Run program. Okay, do we have it here? Run program. Yeah, yes we do. Oh, okay, so maybe this is the next stage. Okay, yeah, this is, I think this is the one that I've suspected that will be the next, and then maybe something will be done with this. Okay. Okay, where have we been? So if we want to go back for where we are debugging right now the code, we go to the RIP here, to this cursor, and jump to disassembly. And again, this function was this mumbo jumbo stuff. Again, let's try to get the glimpse or whatever. So you know what, let's put a break on, because maybe it will exit or something. Do F8, nothing happened. We'll call it mumbo jumbo. Mumbo jumbo stuff. And here, yeah, great. So how many times? Once. Okay, maybe it's something maybe it's something with the algorithm of the extraction of the cap. Again, I'm just guessing. I don't want to really go there right now. Then it compares some value. Okay, whatever. Go to the ver check, and again extracts the resource. Blah blah blah. Checks the version, and eventually. Okay, so where are we at right now? So we are in this subroutine, which is the load of those. Okay, so get module handle. So let's go with the flow again. Okay, so here we go. Interesting here. So it's called the interesting here function. Okay, so now it goes to the cabinet. Again, the cabinet is this file. So again, if you want to go, you can basically go to the first video, Ardamax Keylogger part 1, and see what I did there, which is pretty much where it was like an overview. Now it's more deep. So takes the resource, whatever, blah blah blah, and then you need to, with the time and experience, you will learn which type of code you need to be into, and which type of code you can go and just execute it without, you get the hang of it eventually. So it takes the parameters, as we already saw in the MSDN, use the FDI create, then it returns the value, which is, if we do DDD or whatever, takes this value. Okay, some hexadecimal value, which is the context number for the FDI copy. And before the FDI copy is executed, let's go here and put a breakpoint. No, we don't need to. So let's put a breakpoint, excuse me. So what I like to do is like taking procmon, it says internal tool of Microsoft, and basically let's just stop the event logging. It will basically log any event regarding registry keys, file system, network activity like TCP connect, sockets, stuff like this, and process and thread start and termination. If we do Control X, it will clear it up. Now I want to filter to process name. I called it Ardamax EX, basically Ardamax EX. I can also use the PID or whatever. So it's basically we want to see the process name of Ardamax X. We can do is not less than of the logical expressions to include or to exclude it from the list. Of course, we want to include it. So let's do add and do OK. And while it's executed again, let me just Ardamax X. Yeah, great. So now whatever I like to do is putting this like that, and I want to see what I dropped, because again it's like the FDI copy. Again, let's try to go FDI copy function extract files from cabinets. How it extracts and whatever, I don't really know, but let's see. So F8 and kaboom, we have something here. So okay. Okay, so first of all, let's start with the, again, it's something very important to state that the the results that you see in Procmon, for example, create file, it's not like the how can I explain? The functions that you see, or the operation specific that you see in Procmon, is not always the function, the specific Windows API function, because as you can see, the FDI copy function is used. So why do you see operation create file? Because it's the name of the operation. So basically, in the case of create file, Windows API function and operation basically creates a file literally. If it's not, if it does not exist, but if it exists, it will take a handle or whatever. It will basically receive a handle to this existing file. So we can see it dropped the one exe into this path. C user terminator update a local temp, and it gave this, I think, random blah blah name. Maybe if we execute it again, it will give a different name. Which is, by the way, a great indicator and good behavior analysis. So if you have 1, 2, 3, 4, 5, 6, characters before the .tmp extension, you can understand the behavior of this malware. So if I go to right click and jump to, we can see, yeah, here we go. So this FDI copy is basically our dropping mechanism. So yeah, this is it. So it drops the one exe, install exe, and pretty much, yeah. So this is, it's like already, wow, 55 minutes, and time goes and flies when you have fun. We'll do a part 3 on this because we have more stages to analyze. And yeah, that's it for today. So thank you very much, guys, for being with me here in YouTube. Please do the algorithm things with like, subscribe, the bell button, all of this stuff. If you like my videos, please comment and do the other algorithm stuff. Like I said, again, ready. And if you have some suggestions or requests regarding malware or whatever things that you want me to analyze or research, ping me. Thank you very much. Have a great day and Shabbat Shalom.